Thank you very much, and welcome to the mobile computing session today. We have two great speakers lined up. Our first speaker is Victor Ball. He is the founding director of Mobile Computing Research Center here at MSR. He's also, before that, founded the Network Research Group at MSR, so he is the founder of multiple groups here. Number of patents, number of publications, lots of citations, some thousands actually. I have 12,500, so lots of citations. He's the fellow for ACM, he's a fellow of IEEE, fellow of American Academy of Arts and Sciences, and the list goes on and on. Victor, over to you.
Oh, thank you. Hi. Well, welcome to the Faculty Summit. This is the first day, I guess. It's a pleasure for me to be here, and thank you very much for coming. So I work in an area which is just completely exploding, and I'm exceedingly excited about it. And I hope that you will share the energy that I certainly feel after I'm done with the talk. There's a lot of stuff going on, right? As you know, and I sort of I decided to pick on one dimension of it, which I think holds a massive amount of promise in the near future. So let's start with the obligatory slide, and the obligatory slide is this is the world that is changing right underneath us with the proliferation of smartphones and the way they are sort of being accepted across the world. It's just phenomenal, and it's amazing. Now the question is. So here's some data that you've probably seen, and you've probably seen more and more of this data because the news is full of such graphs. But and interestingly, one point was that the amount of smartphones that got shipped was more than the number of PCs, for example, that you ship. So that's sort of like saying that the old world is changing. Now having said that, let's think about so mobile computing is it for as far as at least I can see. So now if you think about mobile computing, I can talk about these things. And for those of you who work in the area, there's nothing new here. But for those who don't, these are the three big things that you have to sort of keep in mind as you decide to approach research problems in it, right? There's hardware limitations, of course, and even though the processors are getting better, they're getting multi-core, but they will always be limited compared to, let's say, something that is sitting in the desktop or something that is sitting in the cloud. Similarly, wireless communications always problematic. The environment is very hostile, and it's hard to sort of take care of it. And then, of course, there's the energy and the battery use of it. Now, the interesting thing is that I could have put this slide. In fact, I wasn't here at the time doing this sort of thing, but if somebody was there, they could have put this slide 15 years ago, and it would be true. The question in front of us, and for all of you who work here, is that 15 years from now, would we be putting up the same slides? Because this is all, everything here is fundamental. There's nothing that we sort of going to be able to radically change. But we would like to get to the point where we don't think of these as first or highest priority issues that we have to deal with. Okay. So here's a slide that I borrowed or copied from Satya. He knows this. If you know Satya is in CMU, he's been in this mobile computing world for many years. And I really like this slide because he talks about something different. He talks about the human attention. Now, as you think about your phones and mobile devices, you know that this is the kind of a device where you're computing differently from what you do with the PC. That means you're context switching quite a bit. Okay, so you're usually doing something, and you look at this device, and you do something, and you want the answers right away because you want to make some decisions based on the answers you get. Now, of course, that is a serious research problem. Now, the question is that looking at what we have been able to do in computer science, we have very, very rich sets of algorithms and techniques that we have developed in many different areas that we want to actually use to enable this new device that we are using, and to be able to get the answers that we are looking for really, really quick. But then the question comes, we are again resource limited, both in terms of what we have in terms of battery, CPU, and wireless things as well. So Moving on, so what is one of the inherent things? Again, like I said, for those of you in the field, this is nothing new here, but it's interesting to see that energy is. There is no real silver bullet here for us, at least in the near horizon, that will say that this energy problem will go away. And energy, unfortunately, affects everything you do. Everything, your own actions, the way your behavior is with your phones, the way the behavior of developers is. I mean, I'll tell you that there are many things that we do and we know how to do, but they never see the light of day in the products, because the product group guys are so sensitive to the energy requirement of that particular thing that you want to do, that they will rather not ship it than ship it and then have people complain, oh, my system dies in 2 hours, right? So in some sense, a lot of these innovations don't go in there because of that problem. Now, so there's, like I said, there's no silver bullet. And if you think about what we have done with CPU, and when you think about what we have done with the battery, there's a massive amount of difference. So this is something to keep in mind all the time as we move forward. And I mentioned this because in the cloud world, this is where one of the things that we go after directly. Other things, and I sort of alluded to this, is this much more industrial class applications that you want to build. I know you've seen videos on YouTube about augmented reality, for example. You could also say, hey, speaker recognition exists today as well. Or you could say, they're gamings. But the reality is what you see is very simple. It's not the sophisticated kinds of things that the computer should be capable of doing. And so there's a lot more there to be able to do it. And the question in front of us is, how do we get there? Okay. So as the talk title suggests, what you want to do is you want to take the phone, which is available all over the place, take the cloud and do it and marry them or connect them in such a way that you never actually see the difference of where the computation is happening. Now, of course, there are problems here. I mean, the connectivity is a problem and all the other good stuff is a problem, but that's okay, because that's the kind of thing that we can fix and are very good at fixing, okay? So that's sort of the thesis. So if I was to sum it up in this one statement, this is what I would say that we are doing at this current time, and that would be to enable mobile application developers to fully realize the potential of the cloud and to do so quickly and easily. So as a developer, when you write your apps, you don't necessarily worry about where these apps are going to run. They just run, okay? And the systems underneath will take care of that. So you provide a level of abstraction so the developer can think logically and can think abstractly, and then the system will now do this dynamically for it. And that's what I'm going to talk about a little bit here. Now, one more slide, sort of a marketing thing, but nevertheless, you must understand that the reason this is not just me saying, right? This sort of the whole world, if you sort of talk about the developer part of the world, not just the researchers, you see this is what they're saying. So, for example, what this talks about is how big this industry is going to be. I don't know if this is the one I have, but there's the vertical axis talks about dollar counts in billions of dollars. That's a lot of money. And if you look at the statistics, they sort of say most of what we think as cloud computing today is all about emails and some sort of internet access. That's about 91% of what we do. But moving forward, as we bring more and more services to bear, that's going to change. That number is going to drop. This is their projections, but my intuition says that it'll be even more than that. So cloud computing is big business. It's big business in multiple ways, and it's going to get bigger and bigger. Now, so there are 4 things that I want to focus on. I don't believe I'll be able to get to the 4th one, but I wanted to list this for completeness. First is code offloads. And code offloads to sort of save energy on your phones. The next is, how do we cut down the latency problem? Because even when you do code offloads, you have a serious latency problem, which will basically kill your applications. And I'm going to talk a little bit about that. And then finally, I'll talk a little bit about the service and the service composition work, which has been we've been doing for the last couple of years, and is fairly cool. So let's talk about computational offloads first. So what is the research challenge here? Okay, so what is computational offloads? I mean, the idea is you take a certain bit of code and you want to run it in a certain piece of the infrastructure, and it has to work with the code that's running on your device. So the first level question is, hey, what should I offload? right? That's sort of the first question. Then the other one is we need to offload this dynamically. Of course, because if you make static decisions about what to offload, what if you don't have connectivity? What if your connectivity is really, really bad? What if you require some more data than you had initially anticipated that you were going to munch on? So you have to be very cognizant of the environment in which you are before you decide to do the dynamic offloads. And then, of course, the third big bullet is that you want to do it in a way that programmers don't have to think about it, right? You don't need to have a PhD. You don't even need to have a master's to think about where the code is going to go, right? So you have to make it really, really simple for the programmers as well. Now, so let me just get into the strategy. So from a programming model, the way this sort of the idea works here is the following: that you write your code without just logically as you without thinking about what's going to get offloaded, etc. But what you do is you annotate the code with some tags. The .NET frameworks allows you to do that very, very simply. And so when you're annotating the code, you're thinking very simply. For example, is this sort of self-contained code or not self-contained, and things like that. It's not too hard to do that, but you're thinking logically, because you might say, well, I don't want to have this piece of code is actually dependent on something else, so maybe I shouldn't annotate it. Now, you could be wrong in that, and that's perfectly okay. But this is sort of like, think of it as providing hints. Okay, so what's going to happen is, so here's a piece of code, and for example, you will tag this method or subroutine or function or whatever with a tag called remotable. Okay, so that's what you do. Now, what happens is that at runtime, we have this thing called MAUI, that at runtime, when the system starts to run, it'll see these tags. Well, what actually happens is that you generate a binary, and the binary you can actually look for those tags. When you look for the tags, you can take those pieces of code and you can add wrappers around it and things to make it ready for offloading. And so at runtime, you make a decision whether I'm going to be able to move this code over or not. Okay, so that's what the runtime does. Now, one of the interesting point here is that, and this was a very, very important point actually, because whenever you do something like this, somebody's going to ask you, hey, what happens when you don't have connectivity? And the point is, because of the dynamic nature of the system, it is able to handle it. So if there's no connectivity, it's not going to offload. If the connectivity is really poor, it doesn't offload. Now, I said a few things about static partitioning versus dynamic partitioning, and there's some level of discussion to be had about whether static partitioning can work or cannot work. But it is our assertion that static partitioning will actually not work if you decide to do that, and the fundamental problem there is the semantics of the application that you're writing. And if you don't understand those semantics, you could actually end up in a situation where you're doing two things which you don't actually want to do. For example, doing a transaction with a bank, etc. So, if a question comes to your mind that, hey, why do we even need the programmer to deliberately put these tags there? You have to sort of think that's the reason. That the system that you designed, which does it automatically, could lose out on the semantic meaning of the applications and would cause a problem. But that's definitely a research problem and something that we need to think about more and more. However, we can easily get rid of that problem for now, at least, by doing this in sort of a hints fashion. So the way the system works is, so you have the smartphone here, and then you have the cloud. Now, I've sort of drawn this picture, partitioned it in a way that there's only two levels of partitioning. So there's a cloud and the smartphone. Now you can imagine that this can actually be partitioned more. And just keep that in mind, because I'm going to tell you about why you would need to do that. So logically, it really doesn't matter, but logically you can do that. So the smartphone has the client proxy, it has the profiler and a solver. And I'm going to tell you a little bit about each of these things. And then on the server side, you have the same thing, where there's interaction going on between these two components of the software.